Okay, so this video is in response to Jazzy. Oh, fancy. This video is in response to JazziiRed's video. JazziiRed is a Minecraft YouTuber, Redstone YouTuber, who made a video recently about about an automatic minecart railway system. Uh, so I am responding to that because he went through and he designed a thing, and he's like, well, if anybody has any better ideas, is this working? Great. If anybody has any better ideas, let me know. And honestly, I don't really care if he sees this or not. I'm going to leave a link in the description for his video. It's a pretty interesting video. But I don't really care if he sees this or not, because just the thought process and the idea of it was really interesting to deep dive into. To understand this video, you need to understand some basic Minecraft mechanics, such as like the Minecraft video game and what rails are, and maybe some other like bits of redstone. It shouldn't go too deep into that, and then I'll just be doing some general explanations. So to explain his system, he was building a railway system, right? So in this railway system, you have your different stops and whatnot, right? So you have like here and here. I should be using a different marker for on top of that pasted image. Come on, there we go. Okay, he's got here, right? So he's labeled all these different spots, and each of those are the stations, right? And the general idea is each station, the way that he set it up is each station knows the direction of the other stations. So purple knows the direction of yellow, orange, green, pink, red, and white, right? Even though it's technically not, he talked about it in his video where technically this only needs to know if the thing coming through is purple or not. Basically, here's how his system works in a nutshell. Okay, you get a minecart. Okay, your little minecart dude, and it goes around. Inside the minecart, it has a data set, and that data basically just has the name of the stop you want to go to. Okay, so the minecart has some data. That data says, I want to go to this station. And then you start off on a different, so you start off not at that station. So let's say you start here, and then you go to, this spot. This station goes, oh, well, I know where the red station is. I'm going to send you over to the red station. The green station does the same thing. Orange station does the same thing. Each station is hard-coded to know where all the rest of the stations are. Reasonably simple to understand. The big problem with this system is what happens on the expansion side of things, okay? So reasonably understandable system. Each system knows where all the rest of the systems are. The minecart or the data, traveling is has the name of the system that you want to go to, and each system will just go, oh, okay, well, we're just going to pop you over to that system, that station. Okay, each station goes, oh, okay, you want to go to the red station? That's the direction of the red station. So no matter where you send off from, red station is where you're heading because you have the data for the red station. Makes reasonable sense. Okay, cool. So the problem with this system is what happens when you add another rail. Okay, so if you were to add another rail system here, okay, so he has like, right here is his little system. We'll just say this is the black system. Okay, so this is the black railway. Right here, this is the purple one, this is the white one, green, yellow, orange, right? Now what he has to do, let's say it's connected like this. Okay, now what he has to do is he has to go through each individual, let me use a different color for this. He's got to go through each individual station and update all of them so that all of them understand that is the direction of the black railway station, right? So the yellow one would have to go, okay, well, if, the data is, okay, go to the black railway station, then it's like, okay, go this way and go this way. And if it's not updated, it cannot do that, right? So there's a hardwired maintenance in this system that is not nice. There's also a software maintenance system. We're going to avoid that for now, basically, to put the info into the minecart, right? I'm going to pretend that this is legible. To put the info into the minecart, you'd have to do an update, so that instead of on 1.0, where they didn't know about the new railway system, you'd have to update all the stuff and be like, okay, well, now we have the data for the new system, right? Okay, all the new railway systems are on this. We have to update all the data inside all of these systems. Okay, that's the general idea. Okay. Now, I was thinking about this, and I'm like, okay, how can we alter this so that it needs here's the few goals, right? So the few parameters are, we want it to be automatic. Okay, so we want it to be automatic. We want it to have as little maintenance as possible. I know how to spell little. I'm going to pretend that I know how to spell maintenance and say that my mouse just got in the way. Come on. There we go. Okay, we're back. Sorry, I have a little button on my mouse that on my thing that messes with it sometimes. Cool. Centered enough. Anyway, so we want it to be an automatic system, and we want as little maintenance as possible. What he has right now is everything is hard-coded to know where everything else is. I'm not a big fan of this because of how much maintenance it takes when you're adjusting the system. Now, if you add a station to the station chain, right? Or the web of information, you have to always update it every time, and that's just not super nice. Reason that's not super nice should be pretty obvious, but the idea is that this gets implemented into an actual game that you're using, you wouldn't want it to be always, you wouldn't want constant maintenance in all of your stuff. An interesting idea I saw to solve this in his comment section, I forgot who it was by, but it was basically you have like these general nodes and then like branches coming off of that. So you'd have, these different train stations here, and then you'd have this general node connected through like a highway system, right? A main line to another node, right? That way, each of the nodes only need to get updated when the stuff around them happens, and that way you can have large parent node setups that aren't messing with the entire system, and the entire system doesn't need to get updated, right? So this would be like parent node A, and this would be parent node B, right? And then when a node system, when a new train station gets added to the parent, to the parent node, only the stuff here gets updated, and the stuff over here does not need to get updated. It just needs to know, okay, well, if I want to go to the parent node B, right? So if I want to go to the B sector, then I have to do the main rail line, which is a non-automatic rail line, which was the solution that the commenter gave. A few other comments and whatnot. There were some interesting programming ideas. One of the big problems that JazziiRed addresses in his video is Minecraft's updating system. So Minecraft only loads the game when there's a player, right? This isn't technically true where it only loads the game when there's a player. Player has an ER. Anyway, this isn't technically true. There's some other ways around it. But if we're talking in a hardware setup, it gets really nasty when you have to run a super large framework. Basically, you have Minecraft is run on servers, right? And if you're constantly loading the entire, let's say you're loading this whole section here, right? Then you have to load all of the stuff in the railways. So all this game data would need to be loaded all the time if you wanted to automatically update the entire system with some of the code centric solutions that I saw in the comment section. Certainly some interesting ideas for sure, but I don't think that they're super viable in a general public way, because I think that a lot of people use lower level servers, which means anybody who's using just like a classic server with all their friends and whatnot probably can't run a system that's always loading all of their railways. So that's the general idea with that. Now, the solution that I came to was an interesting one, where it's very similar to this. Excuse me, sorry. Okay. Clicked the wrong thing. There we go. Delete button. Beautiful. Let's see. The system that I came up with is way more like this. So we still have parent nodes. Okay, so we'll have like parent node A, and we'll just call it A1. And then, parent node B, parent node C, and we'll just say that these are our parent nodes. Okay? So these are all different train stations. Now, each of these train stations have child nodes, right? So this will be A2, B2, C2, right? And then the same thing for over here and over here. So we'll just say A2. I know how to draw B for sure. And then C2, and this one will only just have A2. Okay. And then if you want to increase the nodes and whatnot on that, you totally can, right? You can just say A3 here and A3 here, right? So this is the system that I was thinking of. What's interesting about this system here is if you set it up correctly, it has as little maintenance as possible and is still automatic, right? So you hardware code it with a few set of rules, and then it makes it so that it is still automatic, but it also has very little maintenance. One of the differences between this system and the JazziiRed's system is it will not have crossing lines like this. One of these lines would not be here. So there's always only one path a thing can take to the parent nodes, rather than having multiple paths. This could be altered if you want it to be altered, but I think the more simple way, which is a little bit more elegant, is just if you have a train station, you want to build a train station. We'll say that we have A3 here. We want to build a train station here, okay? What we do is we just look what's the shortest path to get to. So we just go, okay, the shortest path to get to B is through this guy. So then we'll go through and we write down a path here. And now this is connected, and this will be an A3 as well, because it is the first connection. It is the first connection to this secondary node. So all secondary nodes, all nodes here, parent nodes will go A, B, C, D, right? And they'll just be A1, B1, C1, D1, because they're all connected into the same framework. Now, all connections to a parent node will be labeled A2, B2, C2, no matter which parent node they're connected to. This is important, and I'll get into it in a second. But that's the general set. So it's like, oh, I want to build a station here, right? Okay, then this will be an A3 station connected to C2, right? And that C2 is connected to B1. Now, some of you guys might see where I'm going with this. The idea is we're doing ID tags, and that's how we're going to go through and we're going to send people through the system, okay? Basically, we'll go, okay, where do you want to go, and where are you coming from? You know how a phone number, it'll be like, you know, you'll have your first few digits that are like your state. I'm from the U.S. Fight me. You'll have like your first few digits, and then you'll have, you know, number, and then a dash, and then like 4 more numbers, right? This is a phone number system, and you also have like your plus 44, your plus 1, your plus whatever. This is a phone number. We're basically going to be doing the same thing, but with railroads. Okay? So we'll go, the reason why we're doing this instead of a general railroad system is because one of the other components that JazziiRed was adding was that he didn't like general monorail systems because he thought that it would work better for personal use if it was way more personal centric, which is why I think that we should be running it way more like a phone number rather than running it like a like an actual monorail system, because that's one of the concerns he was adding. Basically, we go where you're coming from. This will be the first number, right? So where you're from, and then where you're going. Okay? And it's just that simple. Okay? So if you're coming from, and this is just the parent node. So this is from, okay? This is from the parent node, and then where you're going. And then it goes parent, child, child, child. Okay? So if you're coming from C1, you go C1, and then you're going to, let's say you want to go to this new node here. Okay? So this one right here. Then you would go, okay, the first stop from C1 is B1, and then B2, and then A3. So then you literally just go B1, B2, A3. Okay? Now this is the data that the minecart's going to have. It's a little bit more data than just the one piece of data. One of the things that JazziiRed was talking about was he was happy with how little data he had. Totally fair to be happy with how little data he had. He had a very, very small amount of data. That's where my mouse went. He had a very, very small amount of data in this set. He basically just had 1 byte of data. Now, in this system, it does get a little bit more, data heavy, but that's because it makes it so that there's way less on the there's way less on the manual upkeep for the hardware, right? So the hardware itself, right, and that would be the different stations. Sorry, I got a burp. The hardware itself has very little maintenance. Okay, so if you were to add let's say you're to add a, station here, connects to here, the only station you need to update is this one. You don't have to update the entire rest of the system, you just have to update this one. The only one that has some really big number of updates is, let's say we're adding another parent station. So we add parent station D, right? So we add D1 to the system. We'll just connect it like this and connect it like this. Okay. That means that you now have to update A, B, and C parent nodes. And that way they know where to send you when they get their data. So let's follow this. There's one more rule. There's 2 more rules that are necessary. The rule number 1 is this data can only be read once, where if it's proper data, right? So if it goes through its proper node, then we can no longer read it. There's a few ways we can do this. One of the ways is, you use a hopper to just pick up that particular data source. So let's say you just have a hopper that will pick up this, item sorter and just picks up that item that represents C1. There's another one that I was thinking where you can somehow maintain the stuff. So if you could put data in, just specify data into a shulker box, and then keep that shulker box with the minecart, it basically makes it so that none of these will read this data with an item sorter because it's locked behind a shulker box, and you keep the data with the minecart. That has some uses. Couldn't figure out how to do that with the 20 minutes that I spent working on this. General idea is data can only be read once, and then the priority of where they get sent to is the parent nodes down. So if you start here, you always get sent upwards until you can no longer get sent upwards. Okay, so the parent nodes are the top of the system, and it prioritizes going up and then down rather than down then up, or just random. That's important. So let's say we start, here. Okay, so we're starting at this guy right here, and we're reading the first piece of data, and it says, send me to C1. Okay, now it can read all of this data, but the only thing that this guy can actually read would be B2 and C1. Or no, this guy specifically could only read C1 because that's the only other route that he has. Now, if there was an A2 rather than a B2, it could also read A2. No, actually, no, this one can only read C1 because it can only go upwards. This guy could read the A3 because there is an A3 here, and it can go down to an A3. But because it prioritizes going up first, then it will always send it to C1 before it sends it to A3. So we start at A3. A3 knows where its parent node is, right? Every node branch knows the direction to send it to the parent node. So no matter where you are, anything connected to B1, so all of the child nodes from B1 know how to send it back to B1. Okay, so we'll start at C1. It moves up. We're now at A2. Okay, and we have not crossed the C1 node yet, so the C1 node stays. It goes to A2. A2 goes, well, I have this guy. I can read this guy as well, because that says send it down this way, but because it's saying send it down, I send it up first. Great. So now we end up at C1. C1 goes, okay, this is mine. Nom. Nom. Great. Where do I send it now? I'm going to send it to B1 because B1 is the only guy that I can send it to. Now, if there was an A2 here, again, it could send it down to an A2, but it always prioritizes sending it up before it sends it down. So it's going to send it from B1 or C1 to B1. It's just going to go straight across, and B1's going to see it and go nom 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 nom. Okay, and then B1's going to read it, and it's going to go, okay, we got A3 and B2. The only thing here that I can send it to is B2 because A3 does not exist in the immediate connection to B1. So it's going to send it down to B2, and B2 is going to go, nom, eat that. And then B2 is going to be like, okay, who can I send it to? Now, if there were other connections to this, that would be important. But because there's only one connection, it goes, okay, I know where to send it. Send it to A3. A3 looks at it. A3 eats it. And then A3 goes, who do I send it to? Nobody to send it to, and there's no data in the system. So I will just go through and send them to the stop. So this is where they stop because there's no more data in the system. That is the general rule set for what I came up with to how to do it. And instead of having a oh, look at that. instead of having a what's the word? Instead of having a hard-coded system of exactly where to send all the stuff to, I would say it's way more useful to just pull the phone book method in Minecraft, where you just go, okay, I have a phone book, and I'll update, this main phone book for every time a thing, comes into it. Every time I make new stations, I can update this phone book, and then you can just pull from that phone book, and then you have a number pad, and this number pad is just set up so that it's like, okay, whenever we'll just say this is the 4 number pad or whatever. In this system, I think you only need a 4 number pad, but it basically goes, okay, input your first one, okay, that's your first bit of data, and then it'll have like one back key and then one end key, right? So it'll have a back key and an end key. If you input the wrong data, you hit the back key. If you input if you have finished inputting the data, so let's say you just want to go to A1, or let's say you're in, you're here now, so you're at A3, and you want to go, back to B1. You basically just go, hey, here's the data. I want to go to B1, end data, and then it just goes and sends you to B1. B1 goes, eats the data, says there's no more data. Okay, send them. And then that is just the system. There's a few other rules that you can do to it to make sure that everything runs super smoothly. General rules, only read once, priority goes up the chain, parent nodes, all the stuff. Basic idea. The rules for the parent nodes is it knows where all the other parent nodes are, and then it knows where its immediate child node directions are. A child knows where its parent node is, or knows the parent node direction and knows its immediate child nodes. And then for the exact updates that you would need, if you update parent node connections, you have to update all the parent nodes. If you add a child node, you have to update the immediate nodes above it in the chain. In that, I would be referring to, in this case, it's like, okay, so I'm going to add a B3 here. So I add a site here, connected to here. Now the only other hardware update is this guy. So you don't have to go all the way up the chain. That seemed pretty clear last time I did it. And then if you add a node amount, you have to update all stations so that they have that new ID. So in this system, a 4-button thing works because it doesn't go, we don't need more than 4 buttons. Okay, but if I increase the amount of nodes, so we have A2, B2, C2, if I add D2 right here, right? If I add D2 right here, we now have to update all the stations and all the buttons so that we now have an extra button for D2. Because we have now increased it going from, oh no, D still works. We'd have to do E. We'd have to add an E, because 4 works, but 5 does not. Just because it goes, A, B, C, D, and you just need 1 button for each of those. And so if you add an E, you have to update all the systems so that it would, so that you have enough buttons for all that. I recommend a 9-button keypad because they're, known in Minecraft. The design for them are known in Minecraft, and the amount of nodes that you can get out of this kind of system is just ridiculous. So unless you're so crazy that you make that many, and if you're that crazy about your Minecraft world, you're gonna be the kind of person who can go through each individual node and update it. But generally speaking, this should be enough for any kind of Minecraft world that you're running. And if you need more than that, there's like a few different ways you can go about it, but I don't think anyone's ever going to need more than 9 keypad buttons. Where am I? Yeah, that was a brain thought project to work through it. Okay, so if you have the buttons already there, you actually don't need to update the button pads. But you do need to update the phone books. So you need to increase, this is the, station number for that station. So if you add a new station, you have to make sure that you have the new number for that station, which makes sense because you wouldn't have the number for that station before the station existed, purely because you wouldn't be able to get there. There's a few different error code handlings that you could do with it as well. If you want to run it, you could make it so that if you input a station that doesn't exist, it gets you as close to that station as possible before it, just ejects you. Those are some other pieces that I'm not entirely sure exactly how you do it. They don't seem too hard to implement, but that's way more of a Redstone question than the idea question. And as much as I love Redstone, it was the idea that really got me thinking on this. Anyway, that's the general set for my solution. I'm basically just pulling off of phone numbers and how they work in a very simplistic sense. But this is just general data management. Anyway, that's the set. Hope you enjoyed the ramblings. Bye.